Hello, welcome back. Today I will solve LeetCode 300, longest increasing subsequence. This question has the most parsimonious description. Given an integer array, nums, return the length of the longest strictly increasing subsequence. So what is the longest increasing subsequence? Let's take a look at this example. Here we have an array, and here are some of the examples of an increasing subsequence. This is not the complete subset of increasing subsequence for this array. The important attribute here is that each number in this subsequence is increasing from left to right. Notice that a subsequence can also be one element. So one can have the element 10. The length of the longest increasing subsequence for this array is 4. That is 2, 5, 18, and 19. Now let's take a look at this example. If we have all the values to be the same, then the longest increasing subsequence here is the array 7. The brute force solution for this problem is to find all the increasing subsequence of the array and then find the one that has the longest length. But this solution won't get you a job. Now, intuitively, when the questions ask you for the maximum, the minimum, or all of something, often this is hinting that there is a dynamic programming solution. And that's what we're going to talk about today. We're going to talk about the dynamic program solution for this problem. The intuition here is that we're going to build a DP array with the same size as the nums array. Using this DP array, we will establish what's the longest increasing subsequence if the array has only one element, 2 elements, 3 elements, etc. And we can build up the solution this way. With dynamic programming, it is important to understand what is each state that we are storing in dp sub I. So just to be explicit, dp sub I will store the maximum length of the longest increasing subsequence up to and including num sub I. Okay, so let's unpack this a little bit. We are saying that dp sub I would be the maximum length of the longest increasing subsequence that includes num sub I. If we had to include num sub I, we know that at a minimum, this will have a length of 1. So the baseline value for the states is 1. This makes sense because at the minimum, an increasing subsequence can have only one element. We can always make an array of the element by itself. That will be an increasing subsequence that includes num sub I. Okay, let's take a look at the first element, the value 10. What's an increasing subsequence here? Well, we can only have this value, so it's 10. So the dp sub I is 1. Okay, let's look at this part of the array. What's the longest increasing subsequence here? We cannot make a longer increasing subsequence than just the 2 by itself. Now let's take a look at this part of the array. The 2 increasing subsequence here are 2, 5, or 5 by itself. So the maximum length of the increasing subsequence here is 2. What about this part of the array? Remember, dp sub I need to store the sequence that includes num sub I. The only increasing subsequence that includes 1 here is only the array 1. So the longest increasing subsequence here is 1. Okay, we continue. This part of the array. Increasing subsequence that include 18 would be 1018, 218, 2518, 518, 118, and 18 by itself. And the longest increasing subsequence is here, is the length 3. Looking at this part of the array, here are all the increasing subsequence that includes 19, and the longest one has a length of 4. Now that we know how to populate the DP array, let's build up the pseudocode. First, we will need a for loop to iterate every element in the nums array and populate the DP array. Next, let's consider any arbitrary position when we are populating the DP array. For example, when we are populating the DP array at this position, we need to determine all the increasing subsequence that includes 5. One such subsequence is the element of 5 by itself. If there are other subsequence that includes 5, what is the value in that sequence immediately before 5? Where is that value coming from? Well, that value can come from here or here. Therefore, we have to iterate the nums array between the element 0 and the element immediately before 5 to check if any of these elements can make an increasing subsequence with 5. And how do we know that there is such an element? Well, that element has to be less than 5 in order to make an increasing subsequence that includes 5. If none of these elements can be part of an increasing subsequence with 5, then we always have the element 5 by itself as an increasing subsequence. Immediately, we understand there's a second set of for loops here when we are populating dp sub I. So the second set of for loop is from 0 to I, not including I. We are asking whether this value can make us increasing subsequence with 5, and whether this value can make us increasing subsequence with 5, etc. The only way we can make us increasing subsequence with 5 is that such value is less than 5, so it's less than num sub I. And that's where we populate dp sub I. Now, importantly, the outer for loop, it does not start with 0 because at num sub 0, we can only make one increasing subsequence. That is the value by itself. There's nothing preceding num sub 0. So the outer for loop, it actually does not start with 0, but it starts with 1. Now that we have this logic in building up the dp array, what is the inner logic here to populate dp sub I? Consider the iteration at this position. And we are going through the inner for loop. We ask, does 10 and 18 make an increasing subsequence? Yes, it can. And how long is this increasing subsequence? Well, it's the maximum subsequence at 10, which is 1. We just append 18 to it, so it will be 2. Okay, then we move to here. Can 2 and 18 make an increasing subsequence? Yes, it can. And how long is this increasing subsequence? Well, it also will be the dp at this position plus 1, which will be 2. Again, we move forward, and at this position, can 5 and 18 make an increasing subsequence? Yes, it can, because 5 is less than 18. And how long is this increasing subsequence going to be? It's the dp sub I at this position plus 1, so it will be 3. So I think we can see the pattern here that when we find an increasing subsequence in each iteration in the inner for loop, the dp sub I is equal to dp sub j plus 1. As we are going through the inner for loop, sometimes we will see a longer sequence and sometimes we will see a shorter sequence. And we always take the maximum of all the ones we have seen. It is worth mentioning that at this iteration, 5 and 18 can make another increasing subsequence with a length of 3. All we know that there is some sequence that has a length of 2 that ends with 5, and we can append 18 to it to make another longer increasing subsequence. We don't know what is the sequence of numbers before 5 is, and we don't really care. It is important to highlight that at each iteration of the outer for loop, where we populate dp sub I, all the values on the left of dp sub I and all the values on the right of dp sub I are constant. They are not changing. The only overriding that takes place is in the inner for loop, where there's a possibility of overriding the length of the longest increasing sequence. Now we've seen the pseudocode, it's easy to code this up. This C# implementation is available in the GitHub links below. First, I will initiate the dp array with the same size as the nums array. And I fill the dp array with value 1 because this is the base value. And then I will have a double-nested for loop. First for loop starts with the element 1, and the second for loop starts with the element 0 all the way to I, but not including I. And then I will check if num sub j is less than num sub I. If it is so, we can make a new increasing subsequence. And then I'll take the length of that subsequence and compare that with all the subsequence we have seen before. And I'll take the maximum of the two as the updated value for dp sub I. When we finish populating the dp array, we will just check the maximum value in the dp array itself. And in C#, we can just do dp.max. The maximum value of the dp array is not necessarily the last value. For example, if the nums array is this, then the maximum value in that dp array is the second last value. So let's talk about the time complexity. There's a double for loop, so this is a O of n squared solution. Okay, let's take a look if this works. And it looks good. As mentioned earlier, the runtime complexity of this solution is O of n squared. This problem also has a solution that it has a runtime of O of n log n. If you want me to make a video of that solution, please let me know in the comments below. Next time we will solve a similar problem. There, we will determine the total number of the longest increasing sequence for a given array. Hope to see you there.